There's a component most of us never even see, yet we literally trust our lives to it every single day. It works in complete silence, under incredible tension, and failure, well, that's just not an option. In the world of elevator engineering, they actually have a name for it, Shahriyan Hayati, which translates to the vital artery. Such a perfect name, right? Because just like in our bodies, it's the absolute lifeline of the entire system. And as the source material from Novin Pooya Elevator points out, one single mistake in how it's chosen or how it's maintained can lead to a catastrophic failure.
So today, we're going to pull back the curtain on this amazing piece of engineering. We're going to unravel the science behind these steel lifelines that really make modern cities possible. We're talking about elevator wire ropes. Okay, let's dive in.
To really understand how you pick the right rope for the right job, you first have to know what it's made of. And trust me, it's not just a simple piece of steel cable, it's a complex, engineered machine all on its own. So let's break it down.
Okay, so at its most basic, an elevator wire rope is built from three main elements, kind of nested inside each other like one of those Russian dolls, but made of high-strength steel. And understanding how these three parts work together, well, that's the key to everything.
We're going to start with the smallest piece of the puzzle, the single wire. This isn't just any old steel. Nope, it's high-carbon steel that goes through a process called cold drawing. Basically, it's pulled through these tiny holes, which forces its molecules to line up and gives it incredible strength. And depending on where it's going to be used, it could be left uncoated, they call that bright, or galvanized with a zinc coating to fight off any corrosion.
Next up, you take a bunch of those individual wires and you twist them together in a really precise helical pattern. That's what forms a strand. Now, this is where it gets really interesting. The pattern they use isn't random at all. It's a very specific engineering choice that directly changes the rope's flexibility and how well it stands up to wear and tear over time.
And then, right at the very heart of it all, you have the core. All those strands we just talked about, they're all twisted around this central foundation. The core has three really crucial jobs. It supports the strands, it helps the rope keep its perfectly round shape even under massive pressure, and it can actually act like a sponge, holding on to lubricant that's absolutely vital for the rope's long life.
And this brings us to one of the most critical decisions in designing one of these ropes. What do you make the core out of? Because this one choice sets up this fundamental trade-off, this balancing act between strength and flexibility, and it completely changes how the rope is going to perform.
So let's put them side by side. On one hand, you've got a fiber core, or FC. Its big win is flexibility and its awesome ability to soak up and release lubricant. But on the other hand, you've got the IWRC, the independent wire rope core. And the name says it all. It's literally a smaller, separate steel rope running right through the center. This thing adds about 7.5% more strength and is incredibly resistant to being crushed, but it's not as flexible. So the question always is, do you need the flexibility or do you need that raw, crush-proof strength?
Okay, so now that we know the anatomy and we understand that big decision about the core, we can start to see how it all fits together. It's really all about matching the right rope to the right elevator. Because let's face it, a 3-story office building has totally different needs than a 100-story skyscraper.
And this table just lays it all out so clearly. You see, for your average low or mid-rise building, you want a good balance of flexibility and wear, so a rope with a fiber core is a fantastic choice. But when you get into high-rise, high-speed elevators, the challenges are way bigger. You're dealing with fatigue, crushing forces, and something called whipping. For that, you absolutely need the strength and stability of a steel core, that IWRC. And for heavy-duty freight elevators, you bring out the big guns, the toughest options there are. Let's just talk about that high-rise challenge for a second. Whipping is exactly what it sounds like. When you have these incredibly long ropes in a tall building, they can start to oscillate or sway, almost like a giant guitar string. This can be caused by the building itself swaying in the wind or just the physics of the elevator moving. It's a huge engineering problem that causes noise and uneven wear, and you need very specific ropes to solve it.
But here's the thing. Picking the perfect rope is only half the battle. You could have the best rope in the world, but if the system it's running in isn't designed just as perfectly, it's not going to matter. There are other factors that are just as critical for safety and long life. Take this number, 40. I want you to remember it. This stands for the D/D ratio. It means the diameter of the pulley the rope bends around, that's the D, has to be at least 40 times the diameter of the rope itself, that's the D.
If you make that bend any tighter, you drastically speed up metal fatigue, and you can just destroy the rope's lifespan. It's a hard and fast rule.
And here's another key number, 10%. When you have a set of ropes all lifting the same elevator, the tension between the tightest rope and the loosest rope can't be more than 10% different. Think about it. If one rope is doing all the work, it's going to wear out way faster, it'll stretch differently, and that can cause vibrations. It just compromises the whole system. Equal tension is an absolute must.
All of this incredible precision comes from an equally precise manufacturing process. It starts with drawing the wire, like we talked about. Then they preform it, giving it that permanent twist to reduce internal stress. Wires are spun into strands, and finally, those strands are closed around the core, all while being soaked in a special lubricant. Every single step is controlled down to the smallest detail. So, as you can probably tell by now, picking the right wire rope is definitely not as simple as just grabbing one off a shelf. To navigate all this complexity, to get it right, you need deep, specialized expertise. That's the only way to guarantee a safe and reliable system. You know, true expertise in this field is this incredible balancing act. For every single project, an expert has to weigh all these different factors: fatigue resistance, abrasion, crushing forces, stretch, and of course, you have to think about cost. It's this complex puzzle where the final answer has to be human safety. And that is exactly where a specialist company like Novin Pooya Elevator comes into the picture. They are that expert guide. They provide the consultation to figure out exactly what a project needs. They guarantee quality by sourcing from the best manufacturers in the world, like Gustav Wolf. And then they offer that critical technical support to make sure everything is installed, tensioned, and maintained perfectly. They handle the complexity, so the final system is safe and optimized for the job. So the next time you step into an elevator and you push that button, just take a second. As you feel that smooth, silent ride begin, maybe you'll think about the incredible hidden engineering of those steel lifelines, those vital arteries working tirelessly just to make sure your journey is safe.